back to the Python for Everyone series, where today we will be discussing functions and then kind of the basics of classes, which we can get more into later. So let's get started with functions. We'll just make our text box, note that we're doing functions. Now, functions are essentially a way to prevent reuse of code again, as I've mentioned in the past, is very important, and so are classes as well. So we'll start out with just a very basic function. Start out, you have to use the def to define it. Let's call it our greeting. This is the name of the function. After the name of the function, you're going to have your parentheses, and then whatever the function will use will go inside of these parentheses. So if we're doing a greeting, let's just say our name. Colon after, it's already kind of doing it for me, but we use f strings. We just want this function to print f string hello, and we can put the name variable in there. All right, we've created our first function already. It's literally as simple as that. And if we want to use this function, just simply greeting and pass in the name. There we go, prints hello Bryce. We could have also passed in a variable, which is where functions really become powerful. So let's say name equals Bryce, and then let's run the function on that. There we go, same thing. Now, sometimes you don't want to just print something. You want to actually save the variables that are in the function. So to do that, you're going to return a value. You can still print throughout the function, but in the end, you want to be returning the value for what the function really does, and after the operation's been done on it. So to exemplify this, we can make a simple calculator function. We'll call it calculator. And what are we going to have to pass? Yes, we're going to have to pass the first and the second number, but we also need an operator. So let's do that, operator. All right, we have our function started now. We have 3 variables that are going to be passed in when we do use the function. So if we want to even start acting like we're using the function, let's just say result equals calculator. We can just pass in that example. All right, let's go back to our function and actually make it. First, what we're going to do is see what the operator is. So if the operator is equal to plus, and notice how we're passing this in as a string. We're also passing it in as a string when we actually use the function, so that is important. And same with these, we're passing these in as numbers or ints rather than strings. So you have to keep that in mind. So if the operator is plus, we're going to return, actually we'll do it like this. We'll say result equals num1 plus num2. And then from that, we can just return result. All right, now remember the elifs. We can do the same exact thing for all the other operators. I'll just kind of tab and skip through that. You can go through that later, and it's really just the same thing at the end of the day. And we can add an else statement on here. Print invalid operator, which will be executed if any of these are not triggered. So let's actually try this now. Do that, let's see what result is. There we go, 30. Worked exactly as we want. So functions are really just performing an operation. Let's say that you have data you want to perform an operation on and you want to multiply them all by each other. That would usually take a lot of time if you did that manually or in Excel. But let's show an example of how functions can make it faster. Let's say we want to have a salary, let's say, or a salaries in US dollars someone has. So let's say salary 1 equals 1,000, salary 2 equals, I don't know, 1,500. We have these. Now, imagine if we had a ton of these and we wanted to convert it. Let's say we wanted to divide their salary by 10. We would have to go through and keep doing it over and over again. Even if we used loops, we'd have to perform it on all those loops and write our code inside of that loop rather than just referencing the function. So we'll see how we can do that. So definition, let's just call it salary divided by 10. We're just passing in the salary. Note how this can just be salary. It doesn't have to be salary 1 or 2. We'll use that when we actually go back and use the function. Simple enough. We're just going to do something. It doesn't have to be called result, but I'll just call it result here. Equals salary divided by 10. And we're just going to return result. Now that we have this function, what we could do is we could do something like salary underscore divided by 10 and run it on one of these. But that would take a long time if you wanted to do that on every single one. Let's say that there were 1,000 salaries. So instead, what we can do is let's put those salaries in a list equals salary 1, comma salary 2. And now that we have them in a list, we can loop over that list and run the function every time we loop over it. So we'll just say for individual salary in salary list, we're going to perform the function. So salary divided by 10, pass in the individual salary that we're currently on. There we go. Now, what might the problem of this be? Okay, yes, we could run it and it's going to perform the function, but what it's doing is it's returning the value, but really it's not storing it anywhere, which is not what we want. We want these values to all be stored rather than simply just executing the function. If we were doing print statements, it'd be perfectly fine to do it like this, but we want to record these new values. So we can just make a new list, salary new, we'll call it. Just make it empty. In this loop, we can simply just take this right here. I don't know, let's call it divided result. And we can append this divided result to our salary new list. Salary underscore new dot append the divided result. All right, let's execute that. There we go, nothing returned, which is what we expected. However, we now have info in this new salary list. Let's look at that. As you can see, it performed our operations. And you can see how this would really save some time if you have longer code. Now that we've discussed briefly about functions, there's a lot more to do with functions, but this is really all it is in the end of the day. It's just how you want to use it. It's up to you as the developer how you want to make use of these functions in a powerful manner, such as through recursion, etc. But that'll be a video for another day. So let's jump into classes. One of the most important things in Python, especially regarding data. Python itself is called an object-oriented programming language, because everything we make is technically an object. Even the inst, let's say the int, the float, all those data types, at the end of the day, they are really just classes. They're built-in classes. Now, what if we wanted to make our own data type? We'd essentially just be making our own class. And instances of this class would be called an object. Just like you have ints and floats, let's say you had a equals 3. This is technically an instance of the class int, if that makes sense. It'll make more sense once we start making the class. But first, it's important to realize always why we're doing the things we're doing in Python, why we would use classes instead of something else. So let's first try to get a list of fruits and without making a fruit class, or I like to call classes almost data types, because that's really what they are, is a better way to store data that's specific and essentially make things in the real world able to be programmed about. So not using classes would look like this. Say we have some fruits, I don't know, a strawberry. We can set it equal to a dictionary. The name of that fruit is just strawberry. Then the color of that fruit is red. Oops. There we go. We could just make a bunch of fruits like that. So let's do that. And just copy it a couple times. Change this to orange. Its name will be orange. Orange. And then we can just do peach, apple, copy in the peach. I guess peaches are yellow, I don't know. All different colors. An apple, I don't know, let's just do a Granny Smith apple, it'll be green. Or, let's call it Granny Smith. All right, as you can see, all right, we made a bunch of dictionaries, but there's some commonality between these dictionaries. They all have names, and they all have colors, and we had to type that all out. It took a long time. And then after that, we'd even have to put them in a list. Let's call that list all fruits, and we're just simply putting all these dictionaries in a list. So all fruits is going to be a list of dictionaries that represent each fruit. And now if we wanted to index that, we'd have to kind of know where it is in that list, which can get annoying. Let's say 0. That'll be the first, that'll be strawberry. And let's get its name. All right, that works. But there's a lot of repetition. What if we had all kinds of different fruits, or even a different class to begin with, or not different class, but different topic that has more than just fruits? You could have, I don't know, types of cars. You would have so many cars to make dictionaries for, and that would just be a pain, especially when there's so much commonality between them. Let's look at how we might use classes to improve this code we just did. Using classes. To make a class, you're just like with functions, how we started out with define, we're going to use class instead as the keyword. And then the name of that class, which is, in our case, just fruit. And once we do this, we can start making our class. First thing you want to do in a class usually is make a initialization function. And we do this by doing definition underscore init underscore. There we go. Now you might be like, okay, where is this coming from? This is just a special built-in Python function. And for us, it will define what the class does once we instantiate it, aka what it does every time we make a new object. So this is where the very basic info can initially be plugged in to the fruit, such as different attributes. We're first going to pass in something called self. Python knows that self means it's referring to the object or that specific instance of the class. It's just something you always have to pass in when doing the inits. Next, we know that each of these has a name. So let's pass in a name, and we know they also have a color. Now what we want to do is we want to actually, with this new object we're in the middle of instantiating, we want to give it these values that were passed in. To do that, we will access the current object, which is through self. We will basically make a name attribute for it and set it equal to the name that was passed in. We can do that again for the color. There we go. We've already made our first class. Very quick. Hit that. And all we have to do in order to start making our fruits again is say strawberry equals fruit. And now what are we going to do here? We have to pass in these variables. We already know that self is automatically passed in because it knows we're making an instance of the strawberry class. So we don't have to include that. All right, now for the name, just do it as a string, strawberry and red. There we go. We just made our first instance of the fruit class. Now what if we wanted to access its name or color? Much simpler than what we did up here. We would just say strawberry dash name or dot name. All right, and we get that. We could have also done that for color. And what if we wanted to make our orange? Same exact thing. Fruit, instantiate it, orange, and it's also orange. And access it the same exact way. There we go. Classes are just as simple as that. Another special thing about classes is that you can have functions inside of these classes. Just like with ints and other like additions, any of that, those have their own functions that they know what to do by themselves if an int is passed in or an int is used. We can also do that with classes, which are, again, our own data type. Let's say we had a warrior. Let's think about what a warrior might do. Warrior class, okay, they'd probably have a weapon. All of them would have a weapon. They'd also likely be on a certain team, and they'd have a certain amount of health. Now these things are in common for the whole entire warrior class. Every single object in the warrior class will have a weapon, it will have a team, and it will have a health, or it will have health points. Now what do we want? These are all called attributes or object attributes, which are really just key value pairs for that specific object. We also want our warrior to do things. I don't know, they might want to attack. They might want to defend. So let's call these our object attributes. And these would be our object methods. Now, the word method just means a function inside of a class. Let's start actually making this now. Just simply class warrior, like that. And then we'll make our init statement, like always. Pass in the object itself, which is the current warrior we would be making when instantiating. To make it make more sense, we can also kind of develop the instance of the class as we go. But we won't execute this yet until our class is made. So let's say we have warrior1 equals warrior. So now, right now it's just super simple. It's an instance of warrior1 is an instance of the warrior class, aka warrior1 is an object within the warrior class. All right, now we also knew it needs a weapon and a team. So just simply weapon, a team, and also the health it will have. Just like earlier, we will set those values. Self.weapon equals weapon. Remember, it's referring to the current object. So in this case, warrior1, you could think of this as warrior1.weapon equals whatever was passed in right here. So let's pass that in right now. Let's say he has a sword. All right, we're good there. They also have a team. Team equals team. Let's pass that in. Let's say they are on the red team. And again, self.health equals health. Let's give this warrior health of 100. All right, great. Now we have this warrior, and it has our three attributes of weapon, team, and health. But the warrior can't do anything yet. So we're going to need to make these object methods for the warrior to actually do something. Simple enough. All we're going to do is create a function that passes in the object, just like we did with the instantiation. This is an object method because we're passing in the object itself. We want it to be able to attack, so we'll just say print attacking. And we also want it to be able to defend, so def defend, pass in self, print, defending. All right, now we should be good there. Let's make that class, and let's also make our first warrior. All right, we have warrior 1 now. Of course, we know that we can get its health. Oops, I passed in the class, not warrior. Warrior 1.health. There we go, health. Or what if we want this guy to attack? Almost the same exact thing, but instead we'll do warrior 1.attack. And you can see we're not passing in anything here because this warrior 1 is essentially already being passed in as the self variable. So let's do that. All right, it's attacking. We can also do it for defending. There we go. Simple enough. We've already made our first class that also has methods. And then moving on from there, what else might you want to be able to do with classes? Well, you might want there to actually be a class method rather than an object method, like we've already been doing. This is specific to the warrior. They can attack. But what if there's a team of warriors, or all the warriors have something happen to them? We would have to make an object or a class method. In order to make a class method, you're going to have to use what's called a decorator class method. And below it, you're going to actually make the method. So let's say, I don't know, global pandemic. Here, instead of passing in self, we're going to pass in the class itself, the warrior class. And right here, we're going to do print a global pandemic happened and warriors have fallen. There we go. Let's see if we can do that now. Now we don't even have to make this. We can run it directly on the class itself because it's a class method. So all you're going to do is this. Oops, not that. We're just going to call, because we have to actually call the function, dot global underscore pandemic. There we go. We just were able to use the class to actually call this method. In addition, our objects can also call class methods, just like this. Let's reinstantiate that. Instead of warrior1.defend, we can do global underscore pandemic. Oops. There we go. It also has access to the class method. Now what about, we've talked about object attributes right here. We've talked about object methods, which is right here. And we've talked about class methods. What about class attributes? Here, we kind of have some customization, and we are actually setting what their weapon is, what their team is, what their health is. We're setting these individual variables for each object, or each warrior object. What if we wanted all the warriors to have some things completely in common? These would be class attributes. You don't even need to do anything special here. Just have it outside of your init function or any other function. Let's just say, I don't know, what's a good variable? Sword, en, blanking on a good example here. But we could do teams. We can set which teams there are. There's red and blue. There we go. We can also keep track of the total warriors made, which is really going to start out as 0. But now thinking again, okay, what if each time we make a warrior, we want this to go up? Very simple enough. We're just going to go inside of our init for, so this is, remember, whenever an object is instantiated, this entire function is run. So what we want to happen is we want to access this class attribute through the capital warrior, which is also right here. we want to access that class's total underscore warriors and add 1 to it. There we go. Simple enough. Oops, comma instead of a dot. Made our class. Let's instantiate that warrior again. Instead of global pandemic, let's get the total warriors. Oops. So it was warrior1 dot total underscore warriors. Oh, oops, it's not a see what I did, I put parentheses. This isn't a method, this is just an attribute. So we'll access it like that. There we go, it's 1. All right, let's make another warrior. All right, now what is our warrior1 dot total warriors equal to? There we go, exactly what we wanted. You can also even add more customization regarding the teams. We can check to make sure that the team inputted was actually a team. So we can check if the team passed through here is in our class's team list. And we're simply going to raise an error if this was an invalid team put in. We'll get into the raise errors and that later. But what we can just see here is that we are raising an error if an invalid team was put in. And this team list is coming from the class itself. There you go. I think that's about all we'll talk about for classes for now. Classes can get much more in depth, which will require a longer video, but should be good enough to get you started and get comfortable before we start moving into the other special methods that classes have, such as add, stir, control what they return. Classes can get really powerful, but you have to understand the basics before you can move on to there. So I appreciate you guys for watching, and I'll see you guys next time.